everyone, and welcome back to our next trigonometry lesson. And in this lesson we are going to learn how to sketch trigonometric functions on the same set of axes. Now in our previous lessons we learned how to draw a sine function, a cosine function and a tangent function. Now we are just going to combine it on the same set of axes. Now they want us to sketch the graphs fx, which is equal to the negative sine of x plus 2, and gx, which is 2 cosine x, on the same set of axes, right? And x is an element of 0 to 180 degrees. Now here is a little bit of a catch, because we know that the period for a sine and a cosine graph is 360. So it takes 360 degrees for a sine function to complete itself, as well as a cosine function. But they only want us to draw it from 0 to 180. So that basically means we're only going to draw half of the sine function and half of the cosine function. Now this is still very easy, because we can just simply type it into our calculator. But what we will do is we are not going to work with a step of 90, because a 90 will just be 90 and 180, and 2 of these sections is not enough. So we're just going to break it up into 45, and we will still work with 1, 2, 3, 4. Okay, got it? So we are just going to make this graph into increments of 45 degrees. So we're going to use a step of 45. Even though there's so many of these, we are just going to use 45. Then we will make use of this first line there, which will be our 45 degrees. Got it? And then this next one will be 90. Then we will have 135, and the last one will be 180. And please remember, we are only going to draw half of the function, because they only want us to draw it from 0 to 180. So let's see what it looks like on our calculator, and you will see it is still as easy as before. So here we go. We type in the mode 3 for table, then they give us fx. We press negative sign and then alpha x, and close the brackets, and then plus 2, and then equal. And then we don't want to put in gx, we want to do each one individually. So 0 is our start, we end at 180, and our step is basically 45. And then we press equal, and there we are done. So look what I do now. I have an x value of 0 and a y of 2. So where x is 0, our y is at 2. So let's plot that point. So that's right up here. Okay, great. Now our second one is 45 and 1,3 if we round it off. So at 45 degrees we're at 1,3, which is not in line with the 1. It's a little bit higher. So let me put in that dot as well, which will be around there. And then 90 degrees is 1, so 90 is right there. Okay, so again let's put in that dot as well. There we go. And then 135, let's just scroll down with our calculator, and there's the 90, there's the 135, and there's the 180, and I can pause right there. So 135 is also 1,29, which will be right there also. So let's put in that dot right at that point there, and then also the 180, which is at 2, which is up there. Okay, so great, there it is. So that's basically our sine function. And now please remember, a sine function, and I'll just quickly put away my calculator here, because we already plotted all those points. So I'll just quickly remind you, a negative sine function will start, and then we will go down. Okay, and I'll draw it quickly up here. So we will start, we will go down, up, and turn, right? But now we are not going to have that second turn, because we're not going all the way to 360. It takes 360 for an entire function to complete itself. So this will just have this bottom turn. So basically this graph will just look like this. So we're going to go down, and then there's the turn at the 90, and then it's going to go up to there. Okay, so that's basically all that we are going to draw. And then we have a cosine function as well. So we are going to set this up like this. There's the calculator work, and we press mode then 3 for the table, press 2 cosine, and then alpha x, and that is it. And we don't have gx, so our start is also 0. We end at 180, and then our step will be 45, and there we go. So let's just pause this and then put this in. So here we go, 0 and 2. So again, 0 and 2, that is where we will start. And I'll do this in red so that we don't confuse the two. So there's the red dot. And then 45 is 1, 4, which will be a little bit higher than the 1, 3. And there it is. And then we have 90, which is 0, way here at the bottom, right there. And let's continue. We scroll down, down, down. And we can go one more, and there's the 180. So basically at 135 we've got minus 1,414, which will be here at the bottom, a little bit further than the minus 1. There we go. And then we've got 180, which is a minus 2, which is all the way down here. Okay, great. Now let's put away this calculator, and there we go. And now let me quickly show you what this graph will look like. And again, it's a positive cosine. So a positive cosine, and it didn't move up and down. So it starts at 2 and it will be a porridge bowl, right? So it goes down like this and makes the turn, and up and then and up, and it makes the turn again. So basically we are only going to draw half of it. So it's just going to look like that first half. So can you see it's going to go down, and then it's going to start making the turn and stop. So basically this one looks like this. It's going to go down like this and keep going down, and then it's going to turn to make the turn. And that is basically what these two graphs will look like. Okay, now I know it looks very strange, but I just wanted to show you that we can draw half of it. Now, what if we change this domain actually to x is an element of 0 degrees all the way to 360 degrees, okay? So basically, if you want to do this on your calculator, your start will be 0 degrees and your end will be 360 degrees. Okay, unlike this one where our start was 0 and the end was 180. So why did I show you all of this? It's simply to show you that an entire cycle is 360 degrees. So here we cannot draw an entire cycle within 0 and 180 degrees. It's only half of the cycle. That's why it looks like this. So if you do this part for 0 to 360 on your calculator, you'll end up with a graph that looks like this. And let me quickly show you. So again, if I want to continue all the way to 360 with increments of 45, then this will be 225 degrees. This will be 270 degrees, 315 degrees, and 360 degrees. Okay, so let's quickly go and plot these points. So on your calculator for 225, you will have 2,7, which will be up here. So I have to draw that dot right there. And let me quickly put it in blue. So it will be around there, okay? Then for 270, it will be a 3, which will be right there at the top. And there we go. So it will be around there. And then for 315, we've got 2.7 again. There we go. And for 360, we are down at 2, which will be right there. So basically this function goes like this. It turns at 90, goes up and turns at 270 again, and it will look like this if I continue going down this line and over the dots, and there we go. Can you see the normal sine function? It goes down, turns, up, and turns. Okay, this one is nicely stretched out. So what about the cosine function? Because with the cosine function, we are basically going to also just change the starting point, which is at 0, and then the end will now be 360, okay? So if you type this now into your calculator, 2 cosine x, the start is 0, the end is 360, and we still use steps of 45, you will see that at 180 we still have the minus 2. Then at 225 we are going to have minus 1,414, which is the same as that value at 135. So I'm going to plot that dot there in red. So there we go. And then for 270 it will be a 0. For 315 it will be 1,414, which will now be here at the top a little bit higher than the 1. And then 360 it will be a 2, which is right there. Okay, so let's just continue with this porridge bowl, and then we can go like this, and it makes the turn and it goes up and it equals out like that. And can you see the porridge bowl now? And that is what the two functions will look like if we draw it for their entire period, or for this entire domain from 0 to 360. So do you see the difference? If we just had to draw a half of it, it doesn't mean the entire cycle is now within that 0 to 180. It's just half of the graph, because it takes 360 degrees for an entire sine function to complete itself, and so for the cosine function as well. Okay, so let's go and draw another one and see how we can combine a tangent function with one of these two functions. Now in this part of the video, we are going to sketch another two trigonometric functions on the same set of axes. Now, this is going to be a tangent function and a sine function. Now, let's just quickly think about this for a moment. Now, a sine function takes 360 degrees to complete itself. That's the period. A tangent function takes 180 degrees, okay? But we want to draw both for 360. So basically it's going to be two cycles of the tangent function, right? But now we also know that our step for our tangent function is 45 degrees and our step for a sine function is 90 degrees. So because we want to draw both, we are going to use the smaller step here, 45. Because 45 and 45 still gives us that 90, but we're just going to have more plotting points for the sine function. So we're going to use a step of 45. We're going to have a start of 0 and we're going to have an end of 360 for both of these functions. So let's start and see what this looks like. So out comes my calculator and then we can start. So first, there's the mode button, then 3 for table, then we type in the tangent and x, alpha x, close the bracket. We're not going to work with gx. We start at 0, we end at 360, and we press equal again. We're going to use a step of 45. There we go, and that is all our plotting points. So basically we're going to work with steps of 45. So this will be 45 degrees. This will be 90 degrees. Then we are going to have 135 degrees and then 180 degrees. And if I move my calculator to the other side, then we are going to have 225 degrees and 270 degrees, 315 degrees and 360 degrees. Okay, that's why my step is 45. We want to work with increments of 45. So our first coordinate pair is 0 and 0, so it's going to be right there, and I'll do it in blue. So there we go. And then for 45 degrees, it's going to be 1. So 45 and 1. Let's plot that point. There we go. And then we also know for a tangent function that 90 will be our asymptote. And it says there error on the calculator right there, right? Okay, it means that there's an asymptote. So let's draw in that asymptote, which is a vertical line which my tangent function cannot cross. And we have to draw in this asymptote. Okay, there we go. So now our next one, if we continue to go down with our calculator, scroll down. Let's scroll down 2 more, 1 and another one. There we go, and I pause right there. So now we know that for 135 we have minus 1, which will be down here. So let me put that point in. There we go. And then for 180, we've got 0, which is on the x-axis there. And there we go. And then for 225, we are going to have a 1. Now, I'm just going to move my calculator again to this side. And we know for 225 it is a positive 1, which will be up here. So let me plot that point. It's just below that little line. There we go. And let's scroll down some more. So 3 more. And there's the 270, which is an error where my asymptote will be 315 and 360. And let's pause it right there. So for 270, we've got an asymptote that goes down there, right? So let me draw in that asymptote. There we go. And all the way down as well. And there's the asymptote. Okay, great. Now, how about 315? That is -1, which is down here. So let me draw that in. And there we go. And for 360, it's 0, which is on the x-axis. Okay, so basically I want to take my calculator and put it away. And once I put that away, this is all the points for my tangent function. It's a positive tangent function, so we know what that looks like. It starts and goes up towards the asymptote, and it starts at 180 and goes down towards the asymptote, right? So let's draw that in. So it goes up, and there we go, towards the asymptote, and from 180 it goes through that point and down to the asymptote. But now that is a complete cycle. The period is 180, but we have to draw it to 360. So this entire graph is just going to repeat itself one more time. So what we do is we start at the 180, which is the same as the 0 for a tangent function. We go up to the 270 asymptote. We start at 360, we go through that 315 degrees, and we go down towards the asymptote. And there we go. That is our tangent function. Now we want to draw in the sine function. So it's 2 sine x minus 1. And again, I am just going to take out my calculator and use it to find my coordinate point. So here is the calculator. There we go. And let's see what our values are. So you press the mode button and then press 3 to access the table. It's 2 sine alpha x, and then close the bracket, minus 1, press equal, and there we go. We don't want gx, so press equal again. Start at 0. We want to end at 360 and press equal. Our step is still 45 degrees. And there we go. So let's pause our video right there. And then you can basically see that our first plotting point is 0 and -1. So x is 0, but our y is -1, so it will be there. And I'll do this in my black pen. So there we go. That's our first dot. And then our second point is 45 and 0,4. So 45 and 0,4 is right there. So let me plot that point as well. So there we go. And then 90 and 1, which is right there. Okay. And remember, we're busy with the sine function. So we've got 0 and -1, 45 and 0,4, 90 and 1. And let's continue on our video here. And we're going to scroll down and down. There's the 135. Let's go down one more. And one more. There's 225. So let's see. 135 is 0,4. And that's in line with that dot that we made there. So there it goes. And let me plot that point as well. There we go. And then 180, which is -1, which is down here. So I'm going to plot that point right there. And there we go. And now I'm just going to quickly move my calculator a little bit to the side here. There we go. And now 225 is -2,4. Now that's -2. -2,4 will be a little bit lower down, so it will be around there. So that's where I'm going to make my dot. And let me put it in. So that's where it is. And 270, we have to scroll down a little bit more. There's the 270. Let's wait 315, and there's the 360. And let's quickly find these points. So 270 and -3. 270 and -3, which will be down there. And I'll quickly plot that point as well. So that's where it will be. 315, if you look carefully, will be -2,4. let's go and plot that point, which will be in line with our other 2 comma minus 2 comma 4, and then 360 is a minus 1, which will be there. And now I can put away this video as well, and once I put it away, we can just simply go and draw our function. Okay, so that's where our video goes, and now let's quickly go and plot our sine function according to these dots, and you can kind of see what it looks like, right? So let's just go through all of these lines. That's why the smaller your steps, the easier you can see what's going to happen. So we're going to go up like this and start making the turn. That is our first turn. Then it keeps going down through these points, and now we're getting ready for that second turn, and there it is, and it goes up and stops right there. Okay, and you can easily see why the amplitude is a 2. It has a lowest value of -3, a highest value of 1. -3 all the way up in line with the 1 is 4 units, divided by 2 is 2. Okay, and remember, a sine function that doesn't move up or down was supposed to start at the origin, but look where it starts, -1. That's why we know it moved 1 down, and that is how we are going to draw it. Okay, in the next lesson we are going from our graphs back to our equations, and then you will see how that works. But see how easy it is with your calculator? Okay, excellent. Keep practicing. See you next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.